Hi guys, and welcome to today's video. Area of a triangle at a year 9 level, but funny enough this actually has a relevance to year 10 and year 12 further maths. Believe it or not, I'm going to end up recording this video 3 times today and just slightly change the examples. Go figure, maths is repetitive. Really good to see you. Are you new to my channel? Yes, well, I'm MaffsGuru, and if you can click the little doohickey in the corner just to subscribe, lets me know you're watching, and it makes this all worthwhile. Over at MaffsGuru.com, which is my website, you can find all these videos organized by textbook and chapter and downloadable notes. It couldn't get more exciting, and it is free to sign up. Thank you very much. Now, areas of a triangle. This is building on the videos we have done previously on sine rule and cosine rule and all of that very, very exciting stuff at a year 10 level. Okay, so area of a triangle. By the end of this lesson, I want you to be able to find the area of any triangle. And you're undoubtedly going to say, but hold on a moment, isn't it just half times base times height? Yeah and no. Unfortunately, there are some confusing and tricks coming in this type of course of work. Now, previously we had the idea of a recap that we did the cosine rule, and that allowed us to find the missing sides and angles when we were given two sides and an included angle. So if you remember, here is the first side, here is the second side, and that is my included angle. Now that was awesome because that then allowed us to use this formula here to find our missing side. What was the missing side we were going to find? Well, actually it was going to be this one here. Now if you don't know why, head back to the cosine rule video, take a look and see what you can learn from it. To find a missing angle, now obviously in the situation we have here, we can't use this formula here to find the missing angle. That's when they actually give us a triangle with 3 sides on it. So in that situation, if we had a triangle here that was 5, 7 and 12, for example, and I wanted to find this angle here, then that is where I would use that formula. Why? Well, because that's the formula to use. The sine rule allowed us to find missing sides and angles when we were given 2 sides and an opposite angle. So again, if we have a triangle here that was non-right angle, the important thing here was it was non-right angle. Otherwise, we'd use Pythagorean trig to do this. And if we had this angle here as 42 degrees, and that was 8 centimeters, and I had this as 5 centimeters, and I wanted to find my angle there, well, I could do by using the sine rule, because the sine rule says if we have a given side and a given angle, then that's pretty much a big sort of hint here, and we've given a given side and an unknown angle. And again, there is a video on the sine rule just about this to help you out. But again, we were given a formula that helped us then sort of plug it into my CAS calculator and spit out some values. Easy peasy lemon squeezy when you know how. Now, obviously, as I say, when we went back to sort of junior school, you were given the area of a triangle as a half base times height, and all of them would have looked something like this. I mean, we might have rotated it a bit, but we have the right angle here, and we knew that this was our height, and this here was my base. And life was good. We just did that times that, and we halved it. Well, as life got more interesting, we started to give you different triangles. We started to move them around a bit and give you different measurements. What does that have to do with the price of fish? Well, when I teach this, I think of myself as this right angle basically being a set of arrows that point to the 2 sides to use. So when I'm going to use base and height in my calculations, I'm actually going to use the 2 that are connected by the right angle. Why? Well, basically, we have examples here where we've got 2 triangles that actually aren't given in the nice way that we had before. They're probably not even right angled in this situation. So what would we have done? Well, we probably would have got a dotted line on here. We would have put a right angle here. We would have said that that was 8 centimeters. We would have said this whole length here was 15 centimeters. And then we would have said, well, off you go. Can you find the area of that? Well, again, if I think of this right angle here, and I zoom all the way in as having a set of arrows on the end, then it basically tells me that my base and height are 8 and 15. Okay, so in that situation, I would know that my area was equal to half times 8 times 15, which would be given by 4 times 15. Now, hopefully you all know what I've done there, because a half of 8 is 4. Makes life a bit easier if I break the calculations down. And 4 times 15 is 60, and in this situation, centimetres squared. Don't forget your units. If you forget the units, to be honest with you, you're stuffed in exam questions. And again, we've got another question here where they can trick us again. There's not a lot of room to put a dotted line inside. And a lot of people go, well, what's the height of this? Well, I would ask you, the height of U is surely the lowest point to the very highest point. Well, this here is the highest point. And if I draw a dotted line going vertically down, well, it doesn't seem to touch any part of my triangle. Well, that's okay, because I can draw an extension line out. And because I know that this one line is vertical and that line is horizontal, this therefore must be my right angle. And again, I could say that this was 10 centimeters, and I could say this was 8 centimeters. And this here is my base. It's the length across the bottom of my triangle. I've got the 10, and so in which case my area here would be a half times base, which would be 8, times height, which would be 10. Again, I can do a half times 8, which gives me 4. Multiply that by 10, which gives me 40 centimeters squared. Okay, that looks like 46. So let's make that look like 40 and move on. All right, so that was that. But now, ladies and gentlemen, we now move on to the idea where we have a non-right angled triangle, or in fact, we're not given the base and the height connected by a right angle. What we are given, blah, 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 is 2 sides and an included angle. Hold on a moment, that sounds like the cosine rule. Oh yes, it really is exactly the same idea as a cosine rule. If you have 2 sides and the included angle, you can find the area of that triangle. Whoa! What do we mean by this A, B, and sine C business, right? So looking at the formula, we're now told the area of any triangle is given by a half A times B times sine C. Now actually A and B are the sides on either side of that angle, and C is my included angle. So this would be A, this would be B, and this would be angle C, which is that lovely little quaint coastal town on the way to the 12 Apostles. Anyway, whole new discussion on the Great Ocean Road. And that's basically all you really need to know. So long as you have 2 sides and an included angle, you effectively just put the information into that formula. You go area is equal a half times one side length times the other side length times the sine of the included angle. All right, let's look at some examples. Always good to look at examples. Find the area of these triangles correct to 1 decimal place, taken from the Cambridge Essentials textbook series. With permission, thank you very much. Find the area of the triangle. Have we given a base and a height connected by a right angle? Nope. Have we been given 2 sides and an included angle? Oh yes. So in which case, let's just do that. So I now know the area of this is a half times A times B times sine of C. What is my value of A and B? Well, A can be 10, B can be 9, and C can be 29. So formula, let's substitute that in. And then we are literally going to solve it. Now I can't do that in my head. I'm going to fire up my CAS calculator, and we're just going to type it in as 0.5 times by 10 times by 9 times by, let's bring the keyboard up and trig, and let's say sine, not that one, finger slipped, sine of 29 degrees, and don't forget to close the bracket. Now I'm using the Casio ClassPad. If you're using the TI Inspire, pretty much the same idea here. Close the bracket, very, very important. Make sure your calculator's in DEG mode, and when I hit enter, I end up with the beautiful value of 21.8 centimeters squared. Why am I doing it to 1 decimal place? Because the question says to 1 decimal place, and it's important to make sure you always read the question. Yay! What about this example? Well, believe it or not, exactly the same. Okay, no different. Have we got 2 sides? Yes. Have we got an included angle? Absolutely. So let's say our area is equal to a half times A times B times the sine of angle C, which gives me a half times 3.4 decimals times 1.8 times the sine of 190 degrees. So 0.5 multiplied by 3.4, no, multiplied by 1.8, multiplied by the sine, if you will, of 190 degrees. Close the brackets, hit enter, and we get the fabulous value of 2 point which says to one decimal place 7 kilometers and squared. Right, don't forget the units have changed in this one, kilometers and kilometers. It must be squared because we're finding the area. They can even flip the triangle upside down. Is that going to mess with my head? Probably not. Why? Because I've got two sides and an included angle. Does the formula change? Nope. So we know the area is a half times A times B times the sine of C. So what is my value of A? Doesn't really matter. 7 times 9 and 9 times 7 are the same. Half times 7 times 9 times the sine of 107 degrees is equal to 0.5 multiplied by 7 multiplied by 9 multiplied by the sine. Oh, I've done it again. All right, my fingers obviously aren't doing very well with this. Multiplied by, let's do the sine of 107. Close the brackets. Close the brackets. And that gives me a fabulous 30.1 centimeters squared. Right, there's 3 examples, all exactly the same stuff. Right now, sadly in maths, they're going to try and trick you because, you know, to really see whether you understand this stuff, they're actually going to throw you a curveball. And sometimes they'll give you the area and ask you to find a missing side length. Now, the first thing is to identify which formula you're going to use. You need to look at the diagram. We've got a side, an unknown side, but it's still a side, and an included angle. And the question has told me the area of the triangle is that. So we're trying to link together area, two sides, and an included angle. Well, my brain now goes, well, there's only one thing to do there, and that is the area is equal to a half times A times B times the sine of angle C. Right, what do we know? Well, we know the area in this case. So I'm going to put 70 here is equal to a half times the value of A, which is 10, times the value of B, which is X. And again, doesn't matter which one of those, A and B, you choose. And I'm going to times that by the sine of 93 degrees. Now, lots of ways of doing this. There's the hard way and there's the easier way. And I'll show you how to use your CAS calculator to solve in a moment. But let's do it the hard way first. Well, because in some exams you may expect to do this using pencil and paper. So I know what a half times 10 is. So that's going to be 70 is equal to 5 times X times the sine of 93. I know I can get rid of this 5 by dividing both sides by 5. So I'm going to divide both sides by 5. So 70 divided by 5, yes, I am doing this on my calculator. Yes, I am a little bit embarrassed. It is 14. Gives me X times the sine of 93. And how do I get rid of a times of sine by 93? I divide both sides by the sine of 93. This is it. So I'm now going to divide both sides by the sine of 93, divide by the sine of 93. That means that goes. Thank you very much. And this now becomes that X is equal to 14 divided by the sine of 93, close some brackets, press execute, gives me 14 point, does it give a degree of accuracy to 2 decimal places, 14.02 centimeters, job done. Now that was the hard way, and sadly if you are at this level, which is year 10 and probably extension work, then you're going to need to know how to do it with pencil and paper. But otherwise, let's do the solve function. Now the solve function is great because when you use the solve function on the calculator, you just put in exactly the equation as it is and then just put comma, tell it what it to solve for, and off we go. So in this situation, I'm going to go and say, right, turn back to Maths 1, and you'll notice I've got solve in a bracket here. Okay, now I'm just going to type in the equation. 70 equals, I'm not going to type a half that way, I'm going to type 0.5 multiplied by 10 multiplied by X. Now a word of warning here, it doesn't matter if they use theta, Y, P, R, always use X. It's there on your calculator to use, so my advice is just use it. Times by X, times by, what do I have, the sine, so I have to go back to trig, of 93, close the brackets. Now that's my equation in. Now I do a comma, and I say to the calculator, okay, can you now solve it for the value of X? Close my brackets to finish the function, and hit enter, and lo and behold, out comes exactly the same value. God, don't you just love a calculator? I do. Absolutely. Here is another example. X, same thing, but now we are having that the area. So they still say here that the area is equal to 70 centimeters squared. I'm not going to do the hard way. Let's do what we can come up with the solve way. So the first thing I'm going to do is write the area is equal to half times 4 times X times the sine of 97. Now I've already got all the hard work in my calculator here, so I may as well just copy down my previous value. Let's see if I can highlight all of this. Yep, is it going to let me highlight it all the way to the end? Yep, so I'm going to highlight and drag it down. Just allows me to keep my values. 70 equals 0.5. We're now going to change that 10 to a 4, and we're going to change 93 to 97. I hit enter, and out comes the stunningly awesome value of 35 point. So that gives me 35 point to 2 decimal places, 26 centimeters squared. And by all means, you can do that using your pencil and paper methods as well. Now, we can combine all of the previous rules we've had, sine and cosine, to help us find areas. So, in this situation, we want to find the area of the following triangle. What do you notice? We've got a side, a side, a side, and an angle. Now, to be able to find the area, you have to find 2 sides and 1 included angle. So I suppose the question is sort of screaming at me, find the value of theta. All right, I've got 3 sides. I want to find the value of theta. So that tells me that the value of cosine theta is going to be given by, well, b squared plus c squared minus a squared, all on 2bc. And I suppose in this situation we have to label the sides. Well, the one that's opposite the angle is going to be a, this is b, and this is c. All right, so knowing that, then we can say that the cosine of theta is given by 13 squared plus 12 squared minus 8 squared, all divided by 2 times 13 times 12. Let's scroll up a little bit. And so we know that the cosine of theta will be given by, let's actually clear down my calculator to give myself a little bit of room to clear all of that. So let's do this as a proper fraction. It's not going to hurt, my calculator can do it. 13 squared plus 12 squared minus 8 squared. Let's do that actually rather than divide sign. Divided by 2 times 13 times 12 gives me the spectacular value of 0.79807 ... Now I'm not going to round at that point because I'll get rounding errors. My calculator can happily do that. So I'm now going to say that theta then is equal to the cosine to the minus 1 of 0.798 ... And so in which case we go cosine to the minus 1 of my previous answer. Close my brackets, don't forget to make sure you're in DEG mode, and you get that theta is equal to 37.053 degrees. Now again, I'm leaving those dotted lines there because this is not my final answer. If you remember, it wants us to find the area. And so we know the formula for our area is given by an area is equal to a half times a times b times the sine of angle C. And we have angle C, which in this situation is theta. So I'm going to put theta in the place just to make that a little bit more obvious. Scrolling up, what are our values of a and b? 12 and 13. So that becomes a half times 12 times 13 times the sine of 37.053 ... degrees. Again, remember to use the value on the calculator to do the dots. Okay, so I'm going to do 0.5 times 12 times 13 times, if you will, the sine of my previous answer, which is this one here. I'm going to drag and drop it into place, close the brackets, and we end up with the area of 46.9999. So actually rounded to 2 decimal places, that's going to be 47 millimeters squared. All right, so there we go. We've used the cosine rule, we found the value of theta, and banged it into our equation. What about the sine rule? Yes, we can use the sine rule. Now remember, the sine rule works when we have a side and an opposite angle, and a side and an opposite angle. But in this situation, we want to try and find the area of this circle. Well, to find the area, circle of this triangle, to find the area, we need 2 sides and an included angle, which means that we actually need to know that angle there. How do I find it? Easy peasy lemon squeezy. We know that angles in a triangle add up to 180 degrees. I'm going to take away 80. I'm going to take away 75, which gives me 25 degrees. So that angle there is 25 degrees. I'm now going to use the sine rule to help me find x. All right, so what do? We know the sine rule is a on sine A equals b on sine B, which equals c on sine C. Now, in many cases, or probably most cases, I don't think I've ever used a C on sine C. It's just there for a little bit of equivalence, but I'm going to use this one here. So we're now going to say let that be A and let that be B. So we have 7 on the sine of 75 is equal to x on the sine of 80, which helps me find my value of x. How? Well, I'm just going to bang in my calculator, to be perfectly honest with you. Okay, so let's see. I'm going to do solve, so I'm going to go math 1, and let's bring up solve. I'm going to go back to my trig, because I can do everything from trig. Put in my fraction there, so 7 on sine, nope, as usual, should use my stylus, sine of 75. Close the brackets, put the cursor there so that I can put it equals in the right place, and another set of brackets, x, and I always use x, doesn't matter what pronoun they give me, I always use x, divided by the, and I've done it again, but this time with the stylus, sine of 80, close the brackets, hit right, and then comma, and x to tell my calculator, please can you solve for x? And it gives me the fascinating value that x then comes equal to 7.1368, and I think this was in meters, yeah. And so meters, is that my final answer? Nope. Am I gonna round it? No. So what I now need to do is use that information to help me find my area. And if you remember, my area is equal to 1/2 A times B times the sine of my angle. Let's write it as theta for a bit of a chuckle. And so filling in the values we got 1/2 times, now we knew one of the side lengths was 7. We've just found the other side length there of 7.1368 ... put it in brackets. And I'm going to times that by the size of the included angle, which if you remember was 25 degrees. Scroll this up a little bit, and the rest of it is all calculated. So 0.5. I'm going to times that by 7. I'm going to times that by my previous answer because it's in the register. And I'm going to times that by the sine of 25. Close and hit enter. And it says wrong argument type. So what on earth have I done here? Okay, now this has happened to me before. And the annoying thing with these calculators is I can't actually use my previous answer. And the reason I can't use my previous answer is because it's actually got that x in it. That's frustratingly annoying, but anyway, we told it to solve for x. So what I actually have to do is I have to highlight my value that they gave me, or most of it, and drag it into place and use that one there. And there's a 3 on the end, I may as well put it in. And now when I hit enter, I get my right answer, which to 2 decimal places will be 10.56 meters squared. And there we go, ladies and gentlemen, that is the end of this video on area of a triangle. Yes, it's been a little bit in depth. We've done some example with cosine rule and sine rule. We've looked at right angled triangles, formulas. Hopefully it's been useful. If it has, thank you very much. Can you do me a favor and subscribe? Shout out on everyone to TikTok or whatever else. And hopefully I'll see you in another video. Take care, stay safe, and I'll see you soon. Bye-bye.